Beta radiation is the one in the middle. And because it's the one in the middle, between alpha and gamma, it's a bit odd. It's not as big as alpha, and not as ionizing as alpha, but it's not as penetrating as gamma. Now, if you think it's odd, you're not the only one, because for 50 years it puzzled the best brains of physics. It is so strange that physicists had to invent a new force to explain it, and even now particles that you can virtually not detect had to be invented to explain it. So you may have some questions about it, even after this session. But here's the basics. Let's start with the nucleus. Sometimes a nucleus is formed with too many neutrons. This can happen in many ways. For example, it can happen in outer space, or in a supernova, or even in alpha decay. To make it more stable, it wants to change this neutron into a proton. So that's where the beta particle comes in. Bang! There it goes, and the neutrons become a proton. So how do you think it does this? The answer is the answer to explaining beta decay. A neutron has no charge, so if it changes into a proton, which is positive, it doesn't lose much mass, but it does give away a negative charge. So to make a beta particle, we want to make a particle which has very small mass and a negative charge. There is a candidate for this role. Have a quick think to see if you can work out what it is. Did you work out that the particle is actually an electron? Now, what are the properties of beta radiation? Well, firstly, we know now that it's an electron. And electrons have not got very much mass, but they have got a negative charge, so the charge is -1. The beta particle isn't just a normal electron though, it's got lots of energy. When it comes out of the nucleus, it goes whizzing out. It whizzes out at very, very close to the speed of light, and that's 300,000 kilometers per second. That's about as fast as you can get. The charge means it can change its direction through a magnetic field. So if you put beta particles into a magnetic field, then they start to move to one direction. But it's so fast that it doesn't have much time to stay in there. Now, when it goes past other particles, like atoms and molecules and DNA, it doesn't have much time to spend when it goes past it. So it whizzes past the first one. It might whiz past 30 or 40, but eventually, because it does have a charge, it's going to take electrons off some of the atoms. That means that it's ionizing, but not as ionizing as alpha decay. So, when you look at beta radiation, it travels a long way in air, and it just zooms through paper. But it is stopped by a piece of metal or aluminium a few millimeters thick, and it certainly doesn't get through lead.